All right, so this is the second part of the 12-1 video. So hopefully you've watched the first half. If not, please do that first. But we are on to example 4. So example 4 says when two six-sided dice are rolled, there are 36 possible outcomes. And luckily for you, they've given you all the outcomes over here at the right. Find the probability of each event. So the probability that the sum is not 6. So we would probably see that as probability that the sum is not equal to 6. Okay, well, let's do this. So the sum is equal to 6. This would be equal to 6. This would be equal to 6. This would be equal to 6. Here is 6, and here is 6. Okay, so there's 1, 2, 3, 4, 5. And then once again, there's 36 total possibilities. So the probability that the sum is equal to 6 is 1, 2, 3, 4, is 5 out of 36. Okay, so if it sums to 6 5 out of the 36 times, that means that the rest, it doesn't sum to 6. So if there's 36 total combinations, and 5 times they sum to 6, that would mean 31 times they do not. And if that's confusing to you, you can just go ahead and count all these, and you'll get 31 out of 36. All right, so part B says the probability that the sum is less than or equal to 9. Well, less than or equal to 9, all of these are less than or equal to 9. This one's equal to, this one's equal to, equal to, equal to. So I have highlighted all of the die that are less than or equal to 9. Okay, so if I just count 1, 2, 3, 4, 5, 6, 12, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That would be 30 out of 36, which is what, 5/6? All right, so that brings us to the complement, okay? So the complements are all outcomes that are not the event. Okay, so if I say the probability that the sum is equal to 6, the complement would be the probability that the sum is not equal to 6. Okay, so it either is or it isn't. And if we're talking about the probability of A, we would say the complement of A is P with an bar over that A. Okay, and we know that 1 minus the probability of A is always the complement, kind of like what we did here. Kind of like what we did right down here. They both add to 1, and the reason they add to 1 is because when we're doing probability, everything is 100%. So 100% as a number is just 1. So if I know my probability of A is 0.45, that means the complement, so the probability that it's not A, is going to be 1 minus 0.45, which is 0.55. Okay, so if I look at B, if my probability of A is 1/4, that means my probability of not A is the rest, which is 1 minus 1/4, which is 3/4. Okay, go ahead and do C and D on your own, and then we'll go over them. All right, so if the probability of A is 1, that's 100%. That means the probability of not A is 1 minus 1, which is 0. And then over here, if the probability of A is 0.03, the probability of not A is 1 minus 0.03, which is 0.97. All right, let's move on to geometric probability. Okay, now geometric probability is pretty much the same as probability, but we're going to put like areas and volumes and stuff with it. So geometric probability is a probability found by calculating a ratio of two lengths, areas, or volume. Okay, so example 6 is an example of this. So it says you throw a dartboard shown. So here's our dartboard. Your dartboard is equally likely to hit any point inside the square board Are you more likely to get 10 points or 0 points? So what we need to do is we need to find the area of 0 points, and we need to find the area of 10 points. Okay, well, the area of 10 points is just this one right here, where the radius is 3. So the area of a circle is pi r squared, which is 9 pi, which is roughly 28.3. Okay, so if we're going to hit this full board, this board here, if each of these pieces are 3, 3, and 3, then that means this is 9, which means the whole thing is 18. Same thing up and down by 18. So the square is 18 by 18, which gives me 324. So the probability of throwing this, if it hits anywhere on the board, is 28.3 over 324, which is roughly 0.09. Or you could say 9%, whichever you wanted. All right, so let's look at the probability of 0 points. Okay, well, notice that's just this shaded region, this shaded region, this shaded region, and this shaded region. Okay, so that would be the square, which is 18 by 8, or 18 by 18, sorry, minus the big circle, which has a radius of 9. So pi times 9 squared. And if I put that into my calculator, I get 69.53. Okay, so if I want to find the probability of hitting a 0, I would just take 69.53 over the entire area, which once again is 324, which gives me roughly 0.21. Okay, so I have about a 1 in 5 chance of hitting a 0. So clearly, we're more likely to get 0 points than we are 10. About 3.5 times more likely. All right, so now we're going to talk about experimental probability. And sometimes experimental and theoretic probability are the same, sometimes they're different. Okay, so this is when we're actually doing an experiment and the probability we get from doing that experiment. So an experimental probability is the ratio of number of successes or favorable outcomes to the number of trials in a probability experiment. It's found using multiple trials of a probability experiment. Okay, so if I look down here, and once again, I know that your notes packet didn't print in color, so you might just want to put blue, yellow, green, and red. So when you refer back to this, you know what we're talking about. Okay, it says each section of the spinner shown has the same area. Okay, so if I wanted to find the theoretic probability, it'd be 1 to 4 for every one of these. Okay, I have a 1 in 4 chance of hitting it, 1 in 4 chance of hitting it, 1 in 4 chance of hitting it. Okay, the spinner was spun 20 times. So when we look at this, here's the results. 5 plus 9 is 14, plus 3 is 17. Yes, that sure is 20 spins. Okay, so for which color is the experimental probability of stopping on the color? The same as the theoretical probability. So this is the theoretical probability. This is in a perfect world, 1 out of 4 times you'll hit these. Okay, but we did an experiment, and obviously it's not a perfect world. Okay, so I'm going to calculate each of these probabilities. So there's 20 spins, so this would be 5 out of 20. This would be 9 out of 20. This would be 3 out of 20, and this would be 3 out of 20. Okay, well, 3 out of 20 doesn't reduce, 9 out of 20 doesn't reduce, 5 out of 20 reduces to 1/4. So red has the same theoretic probability and experimental probability in this case. All right, so let's look at example 8. Now, when you're doing these, you have to pay very, very close attention to the words. They can be misleading or confusing or sometimes not even what you see. So you have to pay very, very close attention to the words that are given. So it says, in the United States, a survey of 2,184 adults age 18 and over found that 1,328 of them have at least one pet. Okay? So if we wanted to, and this isn't what it asked, but if we wanted to find what's the probability that an adult has a pet, would do 1,328 out of 2,184. And you'd get roughly about 61%. About 61%. But that's not what we're asking. It says the types of pets these adults have are shown in this figure here. What is the probability that a pet-owning adult chosen at random has a dog? All right, so let's read this again. What is the probability that a pet-owning adult chosen at random has a dog? Okay, so we don't care about all adults. All we care about is a pet-owning adult. Okay, well, it says right here, total pet owners is 1,328. So how many of these out of 1,328 have a dog? Well, if I go to here, 916, so 916 divided by 1,328 gives me roughly 0.69 or 69%. Okay, so make sure that you're reading the words very, very closely to understand what the author wants you to solve for.